Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. We now discuss the solutions of 4 problems from the section complex numbers, and it is the part 3 of the 3 parts of the video that is devoted for these complex numbers. Right. This is the question that has appeared in the JEE Main exam held on 23rd January 2025 in the second shift. The given problem is the number of complex numbers z satisfying mod z is equal to 1 and modulus of z by z bar plus z bar by z is equal to 1 is. We are given 4 options. Let's now discuss the solution of the problem in detail. Let S be the set of all those complex numbers z satisfying mod z is equal to 1 and modulus of z by z bar plus z bar by z is equal to 1. Let z be the complex number x plus iy where x and y are real numbers. Right. Mod z is equal to 1. Its square is mod z square is equal to 1. That is x square plus y square is equal to 1, which is a circle with the center at the origin and a radius 1. Right. And modulus of z by z bar plus z bar by z is equal to 1. Taking the LCM under the modulus, you will get modulus of z square plus z bar square by z bar is equal to 1. Z bar is mod z square. Mod z square is equal to 1. So, writing for z x plus iy, then z bar will be x minus iy. Then this will imply modulus of x plus iy whole square plus x minus iy whole square is equal to mod z square, that's equal to 1. Right. Squaring both of them and adding, we will get modulus of 2x square minus 2y square is equal to 1. That is modulus of x square minus y square is equal to 1 by 2. Taking of the modulus, you will get x square minus y square is equal to plus or minus 1 by 2. Thus, we have 2 equations in x square and y square. That is, before that, S is the set of all ordered pairs x comma y belongs to R square, satisfying x square plus y square is equal to 1 and x square minus y square is equal to plus or minus 1 by 2. And this is the in Cartesian form, whereas in the above one, this is in the complex form. Right. Right. Now, we take the case 1. X square plus y square is equal to 1 and x square minus y square is equal to 1 by 2. Plus 1 by 2 once, that's case 1. And the next case, we take minus 1 by 2. And solving for x square and y square, we get 2x square is equal to 3 by 2 and 2y square is equal to 1 by 2. Thus, x square is equal to 3 by 4. Then x will be plus or minus root 3 by 2. And 2y square is equal to 1 by 2. Y square will be 1 by 4. Y is equal to plus or minus 1 by 2. So, we will get x is equal to plus or minus root 3 by 2. Y is equal to plus or minus 1 by 2. Now write down the ordered pairs. X is equal to plus or minus 1 by 2, 2 choices. Y is equal to plus or minus 1 by 2, 2 choices. The total 4 ordered pairs can be written. So, these are the 4 ordered pairs that are there in S. in the case 1. Let's go to the case 2. X square plus y square is equal to 1. X square minus y square is equal to minus 1 by 2. And solving, we get 2x square is equal to 1 by 2. And 2y square is equal to 3 by 2. And then x will be plus or minus 1 by 2. And y will be plus or minus root 3 by 2. And the ordered pairs, thus we get 4 ordered pairs again, which are there in S. So in S, in the first case, we have 4 ordered pairs, and in the second case, the 4 more ordered pairs. The total number of ordered pairs that are there in S, that is n of S, will be 8. N of S is 4 plus 4, that is equal to 8. So where is 8? Answer option 1. So the answer to this question is option 1, and that is the detailed discussion of the solution of this problem. And it is a very simple and straightforward question. Let's move to the next question. Right. This question has appeared in the JEE Main exam held on 23rd January 2025 in the first shift. The given question is modulus of z bar minus I by 2z bar plus I is equal to 1 by 3, where z belongs to the set of complex numbers with the equation of a circle with the center at C. If the area of the triangle whose vertices are at the points 0, 0, the origin, C, the center of the circle, and the point ordered pair alpha, 0 is 11 square units, then alpha square equals 2. So to work out this problem, we must find out what are the coordinates of the center C of this circle. Right. We are given 4 options. Let's now discuss the solution of the problem in detail. So we are given this circle, z belongs to C. It's the equation of the circle with center C. Right. Take that and we write modulus of z bar minus I by 2 times of z bar plus I by 2, modulus close, is equal to 1 by 3. This will imply 3 times of cross multiplication, 3 times of modulus of z bar minus I is equal to 2 times of modulus of z bar plus I by 2. For z, we write down x plus iy, z bar will be x minus iy. So wherever there is z bar, we write x minus iy. Now that is equal to 3 times modulus of x minus I times y plus 1 plus is equal to 2 times x minus I multiplied by in brackets y minus 1 by 2. Now squaring on both sides, we'll get 9 times of modulus of x minus I times y plus 1 whole y plus 1 modulus close square is equal to 4 times of modulus of x minus I times of y minus 1 by 2 modulus close square, and that will be 9 times of x square plus y plus 1 whole square is equal to 4 times of x square plus y minus 1 by 2 whole square. Now simplifying, we get this. Further simplification will give you 5x square plus 5y square is equal to 22y plus 8 is equal to 0, and that is x square plus y square plus 22 by 5 y plus 8 by 5. This is x square, that is x minus 0 whole square plus y plus 11 by 5 whole square is equal to 11 by 5 whole square, that is 121 by 25 minus 8 by 5. Adjustments are made and you get 81 by 25, that is 9 by 5 whole square. That is the equation of the circle with the center at C, and the coordinates of the center of the C is 0, minus 11 by 5, and the radius is 9 by 5. We continue in the next slide. Right, that is the that is the circle, and we got the circle equation, and the coordinates of the center C are 0, minus 11 by 5. Right. Now we have to find the area of the triangle with vertices at the origin 0, 0 at C, that is 0, minus 11 by 5, and the point with ordered pairs alpha, 0. And it is given the area of such a triangle is 11. Right. So that is given like that. Now let's recall the area of the triangle ABC, where the coordinates of ABC are respectively x1, y1, x2, y2, and x3, y3 is given by 1 by 2 into modulus of the determinant, first row x1, y1, 1, second row x2, y2, 1, x3, y3, 1. So take this, and this will be equal to modulus of 1 by 2 into the determinant of first vertex 0, 0, 1, second vertex 0, minus 11 by 5, 1, third vertex alpha, 0, 1 is equal to 11. Cross multiply, and cross multiply you will get 2 times 11 is 22, and expanding this determinant by the first column you will get modulus of minus 11 by 5 alpha. Then mod alpha will be 22 into 5 by 11, that is 10. Now alpha square is mod alpha square, that is 10 square, that is equal to 100. Where is 100? Option 1. Therefore the answer to this question is option 1. That is the detailed discussion of the solution of this problem. Let's move to the next slide. Right. This question has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. The given problem is, let the curve z multiplied by 1 plus I plus z bar into 1 minus I is equal to 4, where z belongs to set of complex numbers C, divide the region modulus of z minus 3 less than or equal to 1 into two parts alpha and beta. Right. Then modulus of alpha minus beta equals, we are given 4 options. Let's now discuss the solution of the problem in detail. We are given the curve given by z into 1 plus I plus z bar into 1 minus I is equal to 4, where z belongs to C. Writing x plus iy for z, then z bar will be x minus iy. Substitute here and multiply. You will get this. Simplify, we will get 2x minus 2y is equal to 4. That will imply x minus y is equal to 2. That will imply y is equal to x minus 2. What is this? It is a straight line. That is the curve what he talks about is a straight line. So it is a straight line, let us say capital L, with x and y intercepts. So with x-intercept 2 and y-intercept minus 2 respectively. Yes, this is the line L. Now given the region modulus of z minus 3 less than or equal to 1, it consists of all points that lie that are on this circle and inside this circle. What is the circle? See, modulus of z minus 3 is 1. What is the circle? It is a circle with the center P at 3, 0, center 3 and radius 1. And all those points that lie on this circle and inside the circle is the region R. So this is the one. This is the one. Now L intersects C at this point A 2 comma 0 and at B at 3 comma 1. At A 2 comma 0, at B 3 comma 1. Agreed. We continue the discussion in the next slide. This is the story so far. Given the line L divides the region into two parts, alpha and beta. Look at the picture diagram. This is your alpha, this is your beta. Shaded portion is alpha, unshaded portion, this one is beta. Now we will find alpha. Alpha is the area of the shaded region is equal to the area of the quarter of the circle, 1/4 of the area of the circle, minus the area of the triangle APB. So this is quarter means 1/4 of the area of the circle with radius 1, therefore pi r square, pi into 1 square, 1/4 of it, minus area is half of the base 1 into height 1. So it will be pi/4 minus 1/2. What will be beta? The area of the unshaded region. So you take 3/4 of this circle, 3/4 of the area of this circle plus the area of the triangle. So this is 3/4 of the area of the circle plus the area of APB. That is 3/4 of pi 1 square plus 1/2 into 1 into 1, that is 3 pi/4 plus 1/2. Thus we got alpha and beta. Modulus of alpha minus beta is equal to modulus of alpha written minus in brackets beta written. Simplified, you will get modulus of minus pi/2 minus 1, that is equal to pi/2 plus 1. Where is it? Option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of this problem, and it is an interesting problem. And of course, it is a simple problem. Right. We move to the next question. Right. This question has appeared in the JEE Main exam held on 22nd January 2025 in the first shift. Let Z1, Z2, Z3 be three complex numbers on the circle mod Z is equal to 1. It's a unit circle with center 0 and radius 1 with argument of Z1 minus pi/4 and argument of Z2 is equal to 0 and argument of Z3 is pi/4. If modulus of Z1 Z2 bar plus Z2 Z3 bar plus Z3 Z1 bar mod square is equal to alpha plus beta root 2, where alpha beta are integers, then the value of alpha square plus beta square is. We are given four options. Let's now discuss the solution of the problem in detail. We are given Z1, Z2, Z3, three complex numbers. They are on the unit circle, mod Z is equal to 1. Therefore, mod of Zi is equal to 1 for all I is equal to 1, 2, 3. That is mod Z1 is 1, mod Z2 is 1, mod Z3 is 1. Given the argument of Z1 is equal to minus pi/4. Now recall, if the argument of Z is equal to theta, then what will be Z? Z will be r e to the power of I theta, where r is modulus of Z. So, argument of Z1 is minus pi/4 implies Z1 is equal to modulus of Z1 into e to the power of I, the argument, minus pi/4. Mod Z1 is 1, therefore you get e to the power of minus I pi/4. Argument of Z2 is 0. This will imply Z2 is equal to mod Z2 into e to the power of I0. Mod Z2 is 1. E to the power of I0 is 1. 1. Argument of Z3 is pi by 4. Z3 will be modulus of Z3 into e to the power of I pi by 4. Mod Z3 is 1. Therefore, e to the power of I pi by 4. So, modulus, we now compute this one. Modulus of Z1, Z2 bar. What is Z1? Z1 is e to the power of minus I pi by 4. Z2 is 1. Z2 bar is also 1. Plus Z2 is 1. Z3 bar. Z3 is e to the power of I pi by 4. Z3 bar is e to the power of minus I pi by 4. Plus Z3 is e to the power of I pi by 4 into Z1 bar. Z1 is e to the power of minus I pi by 4. Bar is e to the power of I pi by 4. Mod close square. E to the power of minus I pi by 4 plus e to the power of minus I pi by 4 is 2 times e to the power of minus I pi by 4 plus e to the power of I pi by 4 multiplied by e to the power of I pi by 4 is e to the power of I pi by 2. This will be modulus of 2 times e to the power of minus I pi by 4 is cos pi by 4 minus I sin pi by 4 plus e to the power of I pi by 2 is cos pi by 2 plus I sin pi by 2 mod square. This is 2 times cos pi by 4 1 by root 2 minus I into 1 by root 2 plus cos pi by 2 is 0, I sin pi by 2 is I. So this is simplifying, you will get modulus of root 2 minus I root 2 plus I. That is modulus of root 2 plus I times 1 minus root 2 mod square. Now squaring this complex number modulus, so that will be root 2 square plus 1 minus root 2 square. Root 2 square is 2. 1 minus root 2 square is 1 minus 2 root 2 plus 2. Simplifying, we will get 5 minus 2 root 2. This is given to be alpha plus beta root 2. Thus, alpha is equal to 5, beta is equal to minus 2. Therefore, alpha square plus beta square will be, alpha square is 25, beta square is plus 4, that is 29. Where is our answer? Our answer appears against option 3. That is the detailed discussion of the solution of this problem. It is a very simple and straightforward question. In this video, I have discussed the solutions of 4 problems in detail. They are all simple and straightforward questions. One question was important. Right. I am sure that you have understood the solutions of these 4 problems. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes. I will definitely meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.